First, I would like to introduce myself as my name is Dr. Vijay Bhaskar Reddy, working as Associate Professor in the Department of Humanities and Sciences under the Chemistry Department. So, I am handling environmental science subject. Today, we are going to discuss about one of the renewable energy sources, that is the solar energy. So, today, overview of the topics are going to discuss in this lecture is renewable energy. What is the renewable energy? What is the importance of the renewable energy sources and types of the renewable energy sources, applications of renewable energy sources. So one of the renewable energy sources, solar energy, discussed in this lecture, and advantages or applications of the solar energy. So these topics are going to cover in this lecture. So first, what is the energy? Energy means capacity to do work. So for doing any work, energy is required. So that energy can be neither destroyed nor created, not destroyed as per the Einstein law. So that will be transformed from the one form to other form. But here is the energy will be available in the different forms like a mechanical, thermal, chemical and biological energy. So energy will be available in the different forms. So mechanical, thermal, chemical, biological forms. So what is the main applications? What is the purpose we are using for the energy in daily our purposes? So first and foremost is for the cooking or heating or lightening purpose. Every day we are using for the energy sources. For doing some work. For that purpose, energy will be using. So transporting people and goods for the vehicles from one place to other place. Also some of the energy, either electrical energy or chemical energy or mechanical energy are using in the different vehicles for transporting people or goods from one place to other place. For that also energies are required. So manufacturing of the consumer goods and different equipments also energies are required. In the industries, most of the everyday we are using a lot of energy for different purposes in the consumer goods manufacturing. Conversion of fuels. So this energy will be converted one form to other form. For example, here is one of the example given. Burning of coal. Coal is a burning means that will be produce the electrical energy or mechanical energy. So from the coal is converted to the either mechanical energy or electrical energy. So that is the one form. The another one is the chemical energy to electrical energy. So whatever is the best example for the batteries. For example, if you take the batteries containing the stored chemical energy in the different chemicals are used. For example, if you take the lead acid battery, that lead acid conversion of the electrical energy. So here is the principle is the chemical energy will be converted to the electrical energy. For example, if you take the photosynthesis in the plants, in that principle is the solar energy is converted to the chemical energy. Solar energy will be utilized in the plants for the photosynthesis. In the atmospheric carbon dioxide and water that will be converted in the food. If the food is containing the chemical source, is a carbohydrate. So means solar energy will be converted to the chemical energy. So here is the one energy will be converted to the different forms of the energy. That energy will be widely used in our purposes daily. So now coming to the classification of the energy sources. There are two types of the energy sources will be there. First one is the renewable energy sources. Second one is the non-renewable energy sources. So renewable energy sources means these will be rely in the natural energy sources that will be continuously refreshed and restored in the environment or atmosphere. So means for example, these are the petro plants, animals, solar energy, wind energy, geothermal energy, tidal energy. So these are all coming under the category of the renewable energy sources. The simply say that one will be the refreshed continuously. So non-renewable energy sources means these will be available in the limited amount in the atmosphere or the environment, and over a long of the period you can use continuously and indiscriminate use. So continuously we are using for our daily purposes. Then that will be after some time in the future may be exhausted. So those are called the non-renewable energy sources, like a coal, mineral oil means petroleum, natural gas, natural nuclear power also coming from the radioactive elements available in the earth crust, different radioactive elements. So if once after the some time indiscriminately used our daily purposes for the energy conversion, so that will be not reflected within the span of time. Those energy sources are called the non-renewable energy sources. So now coming to the types of renewable energy sources. There are so many renewable energy sources available. Is the solar energy, is the wind energy, geothermal energy, ocean energy, hydropower energy, biomass energy. So one of the today we are going to discuss about the solar energy. In the previous class also we discussed wind energy, biomass energy, different renewable energy sources are discussed. Today we are going to discuss about the one of the renewable energy sources, solar energy. So now coming to the solar energy. So here is the, what is the main principle involved? What are the mechanism? How convert the solar energy to electrical energy? What is the major cell will be available in that one? What are the applications? So this will be discussed in this one. So in this one, the energy which is derived from the sun. So this solar energy is coming from the sun. So that converted to the either heat energy or electrical energy. So that whatever energy is coming from the sun is known as the solar sun. So it can be used either by direct heating, a sun heat directly, or heat will be directly converted to the electricity, or directly heat will be used for our daily purposes. So that is the solar energy. So here is the photovoltaic cells or PV cells. These are converted the solar energy into the electricity. So main what are the, in this solar energy conversion, photovoltaic cells are used. So for the conversion of solar energy into electrical energy. So here is the traditionally daily we are using with knowing or without knowing, is that traditionally we are using for the solar energy for our daily purposes is the drying of the clothes. That was the one of the solar energy directly used for the drying the clothes. Here the whatever clothes containing the moisture or wet will be dried. So for that purpose we are using the solar energy. And food grains drying. So harvesting food grains. Although after agriculture harvesting, that food grains will be dried. So only source is the sun energy only. That sun energy will be take the moisture containing the food grains and will be dried. So preservation of the eatables. Some of the eatables will be preserved for the whatever moisture. If the more moisture will be there, that easily spoiled that eatable items. So for obtaining salt from the sea water will be slowly evaporated under the solar radiation or solar heat. That will be whatever the salt is producing or coming from the seawater. So means traditionally we are using for the solar energy for these are all purposes. But now coming to the solar energy harvesting devices converting the electrical energy or heat energy, what are the devices, how to harvesting, what are the mechanism involved, we can discuss in this one. So solar heat collectors. So these are the generally either active or passive in nature. These solar heat collectors means the solar heat will be collecting. So sun energy, whatever in the form of collecting in the form of heat, that can be either active phase or passive phase in nature. So passive heat collectors are natural materials. Some of the passive heat collectors. Generally, what are the passive heat collectors are? Generally stones. Generally stone is a lot of absorbing the heat in the daytime from the sun heat energy. That after night time slowly will be released. So like a bricks also, a glass also. These are all the natural materials heat absorbing from the solar energy or sun energy. So now coming to the active solar collectors. So these are collecting the heat from the either through medium, like either water medium is required or water, any medium is required, then the only the heat will be trapped in the materials active. Those are called the active solar collectors. So here is there is no passive means there is no any medium is required. Directly that will be fall down on the surface, that will be slowly heat up after some time. So that is the comparison between the passive heat collectors and active heat collectors. Now coming to the solar cells. So second one is the solar cells. These are also known as the photovoltaic cells. So PV means photovoltaic cells. These are made, generally these photovoltaic cells are made by the semiconducting materials of the either silicon or germanium. So generally silicon and germanium is the fourth group element in the periodic table. From that elements is the widely used for the preparation of the is a semiconducting materials. We can discuss what is the semiconducting material, some of the introduction about this one. So when solar radiation will be fall on them, photovoltaic cells, the SL means is the P-type semiconductor or N-type semiconductor is coming, is the when the potential difference is produced, which class of flow of electrons and produce electricity. So means here the when the solar radiation will be fall down, for example when the solar radiation will be fall down in the solar panel or solar cell, for example this will be considered a solar cell. So in solar cell is the when the potential difference. So in this one there are two types of the semiconductor materials are there. One is the N-type semiconductor material, second one is the P-type semiconductor material. When this potential difference will be produced or difference is produced, which flow of electrons from the higher potential value to the lower potential value, so then automatically produces the electricity. So the same principle will be involved in the galvanic cell or batteries also. So flow of electricity will be flow of electrons from the higher potential value to the lower potential value, that is called the EMF, electromotive force. Here also principle will be flow of electrons. When the potential difference is coming, the flow of electrons from the higher to lower only. So when that one is the electricity is producing. So the potential difference produced a single photovoltaic cell around the 4 centimeter square. For example, a photovoltaic cell containing the 4 centimeter square, that will be producing about the 0.4 to 0.5 volts of the electricity are producing, and that will be converted into the current is the 60 milliamperes. So means here is the potential difference will be produced, then only that will be converted to the electrical energy. So how much of the electrical energy is produced in the specified is the area 4 centimeter square. So that also discussed in this slide. So now coming to the direct solar energy. The solar energy is the most abundant for the all energy sources. Is the simply say this one is the leading for the all energy sources. Either tidal energy, geothermal, hydropower, hydrological cycle, wind energy, solar energy, is a biomass energy. These are all is so energy sources are leads by the solar energy only. For example, if you take the biomass energy means simply say is the whatever is the photosynthesis reaction, the solar energy will be converted to the chemical energy. So means solar energy is a transformed into the chemical energy. So that solar energy leads or major role play in the all energy sources. So the rate of which solar energy is intercepted the earth about the 10,000 times greater than the rate of the which mankind can be consumed. Here is the whatever is consumed. The energy received from the sun is a single year. Energy is consumed from the single year. Entirely captured and would represent the 60,000 years of the total energy. So total energy is the consumption, this one. Now coming to the next slide is the solar radiation. Some of the basics will be discussed. Here is the solar radiation is the maximal when the sun is directly overheaded. For example, when the surface containing this one is directly fall down on the surface. So when the more maximum solar radiation is coming. So when the sun is lower in the sky, the energy is spread over a larger area. So means when therefore the weaker per area of the energy will be absorbed on the surface. So this whatever reduction of the receiving area caused by the cosine angle between the instant solar radiation and the surface normal is called the cosine effect. So here is the one, the whatever in this one diagram will be represented as the is the cosine effect. Now coming to the to reduce the cosine effect. To reduce the cosine effect, the whatever the collectors are tilted horizontally or constantly moved tracking systems. So those are attempted to maintain the angle of incident to close 90 degrees as possible. So means here is the, for example, in this first diagram, whatever is the 90-degree angle, this a lot of radiation, solar irradiance will be fall down on the surfaces. When the solar will be tilted, some of the horizontally, that one is a some of the angle will be created, the surface is the minimal the absorption of the solar irradiation. So that is called the cosine effect. So here is the cosine effect is calculated how much energy will be lost. For example, here the straight is a fall down, that one is the maximal, is a 100%. So that is the G is equal to the 1000 watt meter square minus 2. When the sum of the solar is a energy is a fall down on the surface, that will be some of the cosine effect is coming to reduce the cosine effect. That one is that, for example, if you consider the example of the 30 degrees angle. So if that 30 degrees angle will be substituted in this one, is coming to the 866 watt meter square minus 2. So means here is the original, whatever is a 1000 watt meter square is coming, when the solar radiation will be summed down horizontally, that one. So that is the cosine effect is coming, that is the energy also loss per square area. So that loss is the nearly 13.4% of the loss. So this is the cosine effect. Now coming to the solar radiation. The solar radiation is the fundamental importance of harvesting in the high quality solar energy and deemed to be excellent to between the 10 degrees and 40 degrees north and south. For example, in this diagram will be explained, is the 10 degrees is the north and 40 degrees is the south side. So in this, between this one is the more solar irradiance is coming. So across the globe, that one is the 10-40 between the north and the south is the more solar irradiance is coming. So here is there are two fundamental is the methods are solar energy capturing energy from the sun heat and photo reaction. Here is the from solar energy is converted or divided into two. One is the heat traps. So whatever the solar energy containing, that will be heat is trapping some materials, that heat energy is converted to the electrical energy. So means heat trapping materials will be used for that purpose. So another one is the light trapping coming from the solar irradiance, that light trapping materials will be utilized like a photovoltaic cells. This will be using, that is a converted into the electrical energy. In the both energies, either heat energy or light energy will be converted to the finally electrical energy. Here is the, in the heat traps, solar thermals will be utilized. Different collectors will be utilized for the conversion of the heat to electrical energy. Now in this one, there are four major direct solar energy technologies are used. So one is the concentrating solar power technology. Second one is already we well known, that the photovoltaic cell conversion, that one. Third one is the solar thermal. Fourth one is the solar fuels. So we are going to discuss about the only solar photovoltaic one. In this one, electricity is generated by the direct conversion of the sunlight to the electricity by photovoltaic cells. In this one, major principle involved in that one is the whatever directly is the light energy coming from the sun is converted to the electrical energy by using the photovoltaic cells. For example, here the concentrating photovoltaic cells means, in this one, electricity is generated by the optical concentration of solar energy producing high temperature fluids or materials. That materials are used for trapping of heat engines, and that will be converted by the electricity using the electrical generators. So that principle will be involved in the concentrating solar powers. Is the solar fuels means, in this one, using the solar energy, whatever the one energy is will be converted to the another energy. For example, water splitting, water electrolysis by using the solar energy will be a catalyst. So here is the water will be splitting is converted to the hydrogen as a fuel energy sources. So means this will be a solar fuels will be conversion. So like that is energy will be different hydrocarbons also used. So here is the utilizing the solar energy, the conversion of the whatever electrolysis or photolysis, one compound to the another fuels. Those are called the solar fuels. Now coming to the what are the components will be involved in the photovoltaic cell. In the photovoltaic cells generally generated by the electricity by photovoltaic effect. So here is the N-type semiconductor and P-type semiconductor will be there and diode will be there. N-type semiconductor will be generally doped with the whatever is the third group elements with the either silicon and germanium, and the P-type semiconductors will be doped coming from the doping of the silicon and germanium with the is a fifth group elements. So once this N-type semiconductor will be the electron rich source of the semiconductor material, and P-type is the silicon is the whatever that one is the holes will be there. So here is the when the solar energy will be exposed to the N-type semiconductor, that electron richness will be travel across the P-type to the diode. So here is that is the principle will be involved in the solar energy. So now coming to the third one is the solar cookers. So here is the solar cookers made by use the solar heat by reflecting the solar radiations using some of the mirrors. So it means here the whatever the mirrors will be used as a materials trapping the heat from the solar energy. So here is the heat will be trapped by using the mirrors. The directly on the glass sheet will be covered to the black insulated sheet. Is the black coated the insulated sheet will be used. That is the trapping one of the some of the mirrors will be used. In the diagram will be used that one. Whatever the solar energy is coming from the some of the whatever insulated materials like the mirrors. One reflected that one heat, and then here is the black coated whatever insulated box will be used, that will be heat trapping. So that heat is converted to the electrical energy. So here is the nowadays a lot of new design of the solar cooker is available, that will be the different shapes like a concave, convex, different shapes of the mirrors will be used for the transfer or reflection of the heat for the more energy sources. So fourth one is the solar water heater, directly used for the solar water heater for the our purpose, and solar furnaces also. Here is the a small plane mirrors will be concave reflectors. Is connecting to the thousands of the mirrors and producing a temperature nearly 3000 degrees centigrade. So means large number of mirrors will be collected and connected. So that heat will be reflecting through the mirrors, and that heat is trapping by the some of the materials, heat absorbing materials will be utilized in a large quantity. So that is called the solar furnace. In this solar furnace is producing nearly heat is the temperature 3000 degrees centigrade. So that heat will be used for the further electrical energy. So here is the some of the orientation and positioning of the photovoltaic module. So how that will be positioning? There is the different methods are there. One of the method will be discussed is the method 1. The first method involves the calculating the tilt angle by adding the 15 degrees centigrade to your latitude during the summer time and winter time. Summer time this is the 23 degrees and winter time is the 53 degrees. So this is the solar fuels. Solar fuels already in the one of the method will be there. So here is the solar energy can be used to generate the hydrogen production. So hydrogen is a cleanly burning gas. So that will be used for the fuels as a electrical vehicles. So by split, these are coming from the splitting water or by the hydrocarbons. Some of the hydrocarbons either methane, different ethane, methanol, whatever hydrocarbons are used, that is splitting the hydrogen is coming through the various processes. So means hydrogen is the major important source for the fuel energy sources in electrical vehicles. That hydrogen is coming from the either splitting of the water, various hydrocarbons like methanol, ethanol, ethane, thus coming to the hydrogen gas. This hydrogen can be used as a further purposes as a fuels. So different liquid, notably convenient liquid fuels. Here is the solar water splitting to form the hydrogen and oxygen is a potential means renewable energy production. So here is the same waters will be splitting by in the solar energy, that is called the photolysis. Is some catalyst, different catalyst are using. So splitting the hydrogen and the oxygen, this hydrogen will be used as a fuel energy sources. So what are the major applications of the solar energy? Means solar energy is makes absolutely no noise at all compared to the whatever thermal, So other energy sources, there is no noise pollution. Directly sun energy will be fall down on the photovoltaic cells, collectors, some of the different whatever materials are using, that heat will be trapping or light will be trapping. There is no noise. Solar cells created absolutely no pollution also, like a fossil fuel giving the lot of pollution, lot of carbon dioxide will be emitting carbon monoxide. So this is the solar energy, is that there is no pollution is creating. So oil burning like a release harmful greenhouse gases, carcinogenic carbon dioxide into the air. Very little maintenance is required to keep solar cells in the running. For example, is the once is installed the solar panel, is a minimal maintenance is required. Is the solar panels make quite expensive. For first initially when you bought the solar panels, that only is the expensive, then no need to the long run point of view, you can use more electrical energy will be coming from the solar energy. A number of solar equipments have been developed utilized to heat water, to cook and pump water. Different machineries are working, street lighting, railway signals, in this all will be solar energy will be utilized. So what are the major disadvantages? So is the solar energy is, when the solar energy is no solar, whatever the no sun in the during the rainy seasons, during the cloudy seasons, weather or night times or rainy seasons, that time there is no sun energy will be converted to the electrical energy. So that is the only disadvantages. That one, a lot of advantages are there. Noise pollution, no pollution is a first initially only is the expensive. So these are the advantages and disadvantages. So in this presentation we discussed about the is one of the renewable energy sources, solar energy. In the next lecture we discussed about the sustainability development goals. Thanking you.